Okay, we'll get started. Let me share the screen. Here we are. We're going to share that whole screen. Boom. Okay. So where we left off was talking about catch blocks, right? If you have an exception that can throw some code that can throw multiple types of exceptions, then here's how you do it. So you have some stretch that you put in a try block, all the stuff that you know this might cause problems. And then you can have a different catch block for any type of exception that might arise. Now, it's a good point here to bring in something called the concept of unreachable code. So one of the things that Eclipse looks for is if you have a bit of code where it is logically impossible for the program to ever arrive at it, right? And then it'll give you some kind of warning. For example, we'll put a method down here at the bottom. So it'd be void, call it bad method, I guess. It doesn't take anything, it's very simple. So here's our method, bad method down here. And it doesn't do anything, it just returns, right? So whatever I put, anything before the return statement could execute, but nothing after the return statement could execute, right? Unreachable. And the reason is, once you hit this return, you go out of the method. So if I put some code in here, for example, int x equals 0, x plus plus, right? That's fine. It's syntactically valid and it happens before the return. Even though it doesn't do anything meaningful, it's like, yeah, okay, something happened there. But if I put in something similar afterwards, int y equals 0, y plus plus, I get the error. I get the error that says unreachable code. There's no way the program can ever get to this statement. Because why? Because it'll already have returned there. Now, how this applies to exception handling, essentially, exception is an umbrella class, right? It's the parent class for all these exception types. So input mismatch exception, it's a subclass of exception. Array index out of bounds exception is a subclass of exception. Negative array size exception is a subclass of exception. So there's no way, for example, if I put up here exception E, if one of these other exceptions gets thrown, right, it'll say here unreachable catch block, unreachable catch block, unreachable catch block. This exception block for just the parent type exception is going to capture all the exceptions that could ever arise from this stretch of code, making all these unreachable. Okay, so anytime you have a superclass in one of these catch blocks, you need to put it at the end. You need to put it after all of its subclasses, otherwise you'll get that unreachable code problem. Okay, hope that makes sense. Questions on that? Okay, moving on. And get rid of that then. Hey, you know what? I'm going to leave it. I'll just comment this out. Okay. So back to the slides then. So multiple catch blocks. And the way that process works, it's similar to the other one where we only had one catch block. If I go back a few. I don't know what, there we go. If we go back a few, if there's one catch block, yeah, the exception happens, it gets caught by that, right? Very similar. If there are multiple catch blocks, each corresponding to a type of exception that the try block could throw, then it'll go to the appropriate one. So here, the exception happens at statement 3 here, and it happens to correspond to the exception caught by catch block 3. Yeah, that's where the execution flow will go. It'll jump out of there, it'll just execute that one catch block, then it'll skip over all the other ones to get to the end. On the other hand, if there is no exception, then just like before, it executes all the statements in the try block, skips over all the catch blocks, and proceeds onward. Okay. Last thing in this whole try-catch structure, there's something called a finally block that you can put in. So if we're going to put this in conceptually, it'll be something like this. Try, and then some code, catch, some code, right? I'll even keep it reasonably correct. whatever the exception type is that gets caught there. And last, you can put in a finally block. And some code goes in there. Now, the interesting thing, so for one, the finally block will always execute after the catch blocks. The catch block or the try block. Okay? Whatever happens with the try catch process, the finally block will happen. Okay? So these statements in the finally block, they're always going to execute, which means, here's puzzle part number 2, which means the presence or absence of the finally block has absolutely no bearing on how the program runs, right? So this stretch here, it's exactly equivalent if I simply have some code after. If I have the same code from the finally block and I don't have the finally block, this program runs exactly the same way, okay? So again, to repeat, the finally block doesn't make the program run differently, okay? Because those statements after the catch block, they'd execute in any event. Here, we're just putting them in a finally block. So, fair question, why even have a finally block, right? Why even have a finally block, since it has no effect? Well, if you're doing this at home, and most of you are, right? If you're just making dinky little programs and doing it solo and nobody's ever going to look at your code that you make, really, yeah, there's not a lot of point to it. However, if you're coding in an enterprise environment where many people might look at your code and need to update it or change it, right? The updating is changing, or borrow it for reuse. It's nice to know very quickly that the finally block is part of some group structure that is logically coherent. Okay, so the point of doing it, this stuff in this finally block, it's to help other programmers know that this is part of what's going to happen. This whole try catch finally thing is one complete logical operation. For example, your try block might do something like, right? You might do something like get the input, right? And your catch will present an error message if, right, if the input was improper in some way. And then the finally block, what would the finally block do? You know, it could update the, you know, the relevant database fields, for example. Whatever you're looking at in a database, it could do update that if possible, right? If the input was valid. So this whole thing, try to get the input. If it doesn't go through, do that. Afterwards, right, if it's possible, you can update the relevant database fields, or else, or else fail, whatever, okay? This is all one complete logical unit. It's going to accept the input and process it as best as it can, okay? If you didn't have the finally block there, right, you can imagine that this try block, there's lots of code before and after the finally block, right? Lots of code after. So when you group it all together like this, it's much easier for another programmer to look at your code and say, oh, here's this thing. This makes sense. Okay. Hope that all made sense. Questions, comments, thoughts? How's everybody? So? All right. Well then, moving on. All right, so try, catch, finally control flow again. There's a try block, an exception happens, the execution flow jumps to the relevant catch block, and then executes everything in the finally block. On the other hand, if there is no exception, go through the whole try block, skip over all the catch blocks, then execute whatever's in the finally block. So again, regardless, finally block, if it's there or if the statements inside it are just presented outside of finally block, no effect on how the code runs. Okay, it's just for basically for group work purposes. Okay, now next thing, propagating exceptions. This is an interesting thing. So remember the other day we talked about the stack, and we introduced this idea that an exception could be handled locally or it could be handled somewhere else. Look at all these people rolling in. Okay. So one thing an exception can do is it could volunteer to, handle the exception non-locally. Say, I am going to throw this exception, but I'm not going to handle it myself. Okay? The way we do that is we put in the method header the relevant phrase, throws input mismatch exception. That says this method could throw an input mismatch exception, and we ought to have some method in place for dealing with that. So let's make a simple class here. We'll call it fun with exceptions 3. That would be wonderful. We got this. Okay, and what we're going to do with this one is we are going to let's put in a password. Okay, we're going to put in a password and we'll verify that it's 8 characters long. Something simple. So import java.util.scanner. Okay, this one we got this. We're going to say fun with exceptions 3, f equals new fun with exceptions 3. Okay, and we're going to give it some kind of get input method. f.get input, whoop, and we'll do f.set password. Okay, so we're going to have this fun with exceptions. We're just going to give it a piece of data here, string password. Okay, and we're going to have a string get input. Start with return null, that's fine, and then void set password string pass. And make that private. All right, so both of these, this is a private one. This one can be fine. Okay, so for get input, we're going to do our usual thing, right? We're going to say system.out.println, please enter your new password. It must be between 8 and 12 characters. Okay, so we have to have a reasonable password length. So then we'll have, well, we're not going to handle it locally. So we'll say string s equals, where's my thing? New scanner system.in. Next. Okay, so whatever we enter in, that's what we're going to get. And then we're going to return the string. So return s. Okay. Now, if we wanted to have this throw an exception, suppose we have something, we create 2 new exception classes. Okay, so we'll do class short password exception, and this one will extend exception. like was, hello, what's happening? I'm lecturing. Yeah. Anyway. And then long password exception, extends exception. Okay, so we got these two. Now, if the password is too short, I'm going to throw an exception. So I'm going to say if s.length is less than 8, throw new short password exception. Okay, what are we doing? What do we got here? Oh, independent. Did I type it in there? Oh, because I'm not doing it right. So sorry, tripping out a little bit. Else, if s.length is greater than 12, throw new long password exception. And again, it'll show an error for this. It's not going to like this. Now, so I have this method here, and this is the proper syntax if I want to these check for new exception types not inherent in Java, right, in the Java language. Programmer created exceptions. Okay. But if I want to have these handled, I need to put this magic phrase at the top of string.getInput, right? So I can say throws short password exception, comma, long password exception. Okay, now with this, what I've done, this method can throw exceptions, but when I call it, right, it can throw an exception, yes. So what is not taking a string? Oh, string. Let's do a string. String. I'm just going to input it in here. I'm going to do it here because it's a little bit clearer to do. Okay. Now here I need to set a long S. Okay. Now finally the errors have caught up. So one of the things you'll see with an IDE, there could be errors that are lurking, but until you fix some of the other errors in it, it doesn't quite notice that they're there. So the way I have it right now, but I have this method getInput. It can throw exceptions. It doesn't handle them locally. Okay, so I'm going to put that as point 1 here. Point 2, this method call, f.getInput, could throw an exception. So when I call it, I need to make sure I am prepared to handle that exception. And here I'm not, so I get an error. However, if I embed this in a try block, I can do something like try, right? And let's put all these things in here. And then catch, I'll do the first one, short password exception E, and then another one for catch, long password exception E. Okay, so what I'm trying to do here, I get the input, I want to set the password. So to do that, I have to embed that method call in a try catch sequence. Okay, and then I know, okay, this method call getInput, sure, it could generate some exceptions. I'm prepared to catch them. Right? So here I might write system.out.println you know, password not updated. Password must be at least 8 characters. Okay. Likewise for this one, same thing. Password not updated. Password must be no more than 12 characters. Okay. So those are the 2 exceptions I get. Now, of course, here's the fun with it. I can put this inside in its own, you know, method, void, or something. Let's do Boolean. Update password. Okay. I take all this stuff. I'm going to put it in here. What's going to happen? I'll show you. Okay, so this first one, if I get to here, okay, what's this? Oh, F. If I make it to here, I return true. But if I don't make it to there, if I exited the try block, right, without updating, return false. So return false. Okay, so this is fine so far, right? If I do this catch stuff. But one thing I could do, I could have a string of method calls. For example, I could call f.update password, right? And that's fine, right? Because update password handles all this stuff. But likewise, I could put this in a try catch block. I could do, you know, do, okay, I do Boolean success, Boolean update. I could do set it to equal false because the update hasn't happened yet. I could do update equals f.get password while, and repeat as long as update is false. Now I could put this in a try catch block as well if I wanted to. I could do, you know, I could pull all this stuff. I'm going to just put in this. What do I want to do? I do the same thing. I'm going to do throws short password exception and long password exception. Okay, it's going to do those. Now, how do I do the same thing? Well, in this method, I'm simply going to say this part, string s equals get input. I'm going to put that up here at the top. We're going to restructure this. And set password s. Okay, if I get to, if I throw the exception, then it's going to say this thing is still false, right? That's not going to happen. But otherwise, if the update does successfully happen, I'm going to return true. Okay, now here's the thing, this, get rid of this. Put this in its own try catch block. Okay, so if something fails with this, if this method throws an exception, it's not going to change update. Okay, if it doesn't change update, update's going to remain false. Right, so these catches, the update will still be false. But if this executes successfully, it's going to return true. Okay, then update will be done. That'll be fine. So the point is, I can have a long train of, right? I can have a sequence of these things. In fact, I don't even need this. I can get rid of this part here. No, I didn't like that, so I have to try that. I have to throw it. All right, so because that one, that was a little strange. Sometimes these things don't work quite so perfectly. What am I doing here? Okay. Well, anyway, when I'm calling this method, if I'm not going to hand it locally, I have to mention that I'm going to, that it could throw these specific exception types. So you'll see sometimes there's a little bit of variation in how these happen. Part of the reason why this happens is because I'm extending exception directly. Exception is what's called a checked exception type. Other exception types aren't. So if I create a subclass of exception, it's still going to be a checked exception type, and I have to always process it. Anyway, let's get back to the lecture. Okay, but here's what I've done. Let's run this. I want to 8 and 12 letters. I'm going to do a short one. Hey. Okay, has to be at least 8 letters. Great. And I'll do hey, 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 which is 15 characters. No, no more than 12. Okay. Hey, hey, hey. Great. Password accepted. Okay. All right, I should print out a confirmation. I guess if I wanted to, I could do finally system.out.println password updated. Okay, so do something like what? F dot password equals, yeah, I need to retrieve that password, don't I? Well, I'll have a thing called temp that is created here. So string temp password. That's fine. I should put that here. I really don't want to put this in a finally block. Okay, I just put this in the try block. I was thinking I was going to, but I won't. Put it here. Okay, so here, whenever I get the password get input, I will say temp. You do this. All right, that's great. And here. Oh, set pass. Well, that's why I never did this. Okay. Yeah. Fine. I don't need set password anymore. That's fine. Okay. This is good then. I'm updating the thing, right? So if it goes through, I'm saving the temp as an object for fun with exception as a data field there. If it goes through, great, and if it doesn't, that's okay too. Okay, so let's do a final password updated to f dot password. Sure. Yeah. Okay, good. So anyway, yeah, you can throw exceptions. You don't have to handle everything locally. You can always kick them back to some other method to have them handled. Now, one way to do that is just to put that word in the method header itself, to just say some method throws an exception. And you can say, if such and such event happens, throw new exception, just like I did here in this code, right? Down here in the get input, if the password was less than 8 characters, I throw a short password exception. If the password is more than 12 characters, I throw a long password exception. Okay, so I embed that in there. Now, a method that throws an exception, either one that happens in the method, which is directly, or indirectly, it passes backward an exception that happened in some other method, it's called an exception thrower. That's something, it can create the exception. Okay, an exception can occur that method has to deal with. And anytime there is an exception, it has to be one of 2 types. It has to be either a catcher that can process it locally, or a propagator. It kicks it backward. Okay, so key things. Any method that receives an exception has to deal with it. Okay? Even if it's direct, the exception occurs in the method itself, or indirect, the exception is received from another method. Okay, so if this method calls some other method X and X generates that exception but doesn't handle it locally, kicks it back to this method, then this method still has to deal with it. So the two possibilities are, number one, handle it, or number two, keep on passing the buck, right? So this method could itself propagate the exception to the method that called it. Okay, but you have to deal with it somehow, and you have to pick. So, all right, so an exception catcher is one that's going to handle it, and the way it handles it, it has the catch block for it. A propagator is one that's not going to handle it locally, and it will not have a catch block for that exception type. And you can always have a method catch some of the exception types, but not all of them. So it says here, method may be a catcher of some exception types and a propagator of others. Yeah, you can do that. Okay, that's legal. But somewhere, any exception that is going to be what's called checked has to be handled somewhere in your code. And if an exception happens, even if it's not directly handled by your code, then what's going to happen? That exception will get kicked back all the way to the main method. The main method won't have a place to handle it, and the program will crash down to the virtual machine. Okay, so here, this is an image of the stack. Remember, we talked about the stack on Monday. So here we have a method A that calls a method B, that calls a method C, that calls a method D. Now, if an exception happens in method D, right, it says here, some condition is true, then throws a new exception. Well, D is going to kick it back to C. D doesn't have any place to deal with the exception locally. It's just going to say, throw it back. So fine. D kicks it back to C. Well, C doesn't have any way to handle this exception as well. So it's going to kick it back to B. B, of course, has a block to handle this exception type. So it's going to catch that one, right? And that means that A is never going to see it. It's going to get handled as locally as possible to where it happens. In that case, that's B. And that creates the least disruption of the stack. So whatever's going on in A is going to keep on sailing smoothly along and never know that this exception happened. Okay. Now, there's a little bit of a chart here coming up. So all these types of thrown exceptions, thrown problems, they're instances of what's called the throwable class, or its various subclasses. Now, there's two big branches of this, of throwable. Number one is the error class. The error class, they call it here serious errors, but error is usually reserved for things like hardware defects or machinery in the computer not working correctly. Other things that are normal and caused by temporary transient conditions, like the user enters in the wrong input type, or one application tries to access another, but it's not temporary, it's not available at that moment. That sort of stuff is generally handled by the exception. I mean, there's no mandate in there that you have to do it one way or the other, but this is generally how it's done out there. And it basically means, yeah, you see an exception, oh, something happened with the program, but it's not something that we need to really evaluate our whole system architecture about. An error, on the other hand, is something that, yeah, you're like, wow, this is really serious, and this is, maybe we did this whole thing wrong, or there's something very seriously wrong with our IT hardware. Okay, so here's a little bit. This is old, and there are surely many more classes now. I don't have the number at the top of my head, but this is like from more than 10 years ago. So these are just the basic ones. Many of these we've covered. So error and exception are both subclasses of throwable. Exception has two families. They have one that's runtime exception. That are all the things I've mentioned that are not checked exceptions. Other ones, some of these are checked exceptions, like IO exception. That stands for input output. We'll cover that next week when we do file transfers. So IO exceptions are checked exceptions. Likewise, exception is a checked exception. Essentially, that means you have to have some mechanism in place to deal with these kind of exceptions. These other ones, nah, you don't. It's often a good idea, but you don't have to. The Java language is not going to mandate that you do. Okay, so I will introduce that. So checked versus runtime exceptions. So there are two types of exceptions, checked and unchecked. A checked exception is one that is the program looks for it when you're compiling it. And if you're compiling the program, that means you've written the code and you're about to compile it so it can actually run. Well, if you have a checked exception that can occur and you don't have any exception handling mechanism in place for it, your program will not successfully compile. This basically means some exceptions are serious. You want to have them already in place and checked before you make this software live. The idea is, Java is intended for large-scale enterprise usage. There are certain errors that you want to make sure are covered. For example, if you're running some big banking application where you have thousands of people at any given moment connected to a server, and there's some little action that could happen that could crash your program all the way down to the main method and then out, right? Everybody would lose their connection. It'd be a huge hassle. You'd have to, reboot the server, reconnect everybody. You don't want to do that over something simple that you could have coded in the first place. So that's the idea with these checked exceptions. It's kind of a pain, but the logic of it is these are fairly easy to fix and catch and process before the application is live, and it's going to save you a lot of time and trouble later. Other exceptions are what are called unchecked or runtime exceptions. They can only occur and be detected when the program is running. So you don't have to catch them. It's often a good idea to do it, but your program can still compile, and these exceptions can happen at runtime. If it's a checked exception, that means, yeah, the exception could happen while the program is running, but you have to have exception handling in place for it before you can even start your program. Okay, now, different thing. Let's give another example of that. Well, we've already seen it, right? So I can do, for example, do another thing like I'll just make a method for it. I won't really do anything with it. Int get value. Okay, and I'll do return new scanner. Whoop. Okay, so here I'm going to say please enter a number, an integer, an int value. That's good. Okay, now we can see with this, right? We've seen this before. This method isn't integrated with the class. It demonstrates a runtime exception. Okay, so this next int, as we know, it can throw this exception, right? We've seen it before. It can throw input mismatch exception. If I enter in a text string that's not a valid int value, or if I throw in some numeric value that's not an int, right, like +3 trillion or 5.2, that wouldn't be valid for an int, then it's going to throw that same exception, right? It's going to throw that input mismatch exception. But because that is a checked exception, I don't have to do anything like that. What I can do, however, I could do something like this. I could do int value equals this. Now, if I put in and return value, I could do if, right? I could throw that exception. I could say if value is less than 0, throw new exception. Okay, and by doing that, I have suddenly implement this, right? It says unhandled exception type exception. Because this is a checked exception, it's not going to work correctly. I know that this line here, this could throw an input mismatch exception. If I do this, throw new, once I include it, right, then still this becomes effectively a checked exception. It's not, oh, I'm not importing it. Let's see. Import java.util.input mismatch. It still likes that. Okay, so right here, an input mismatch exception, yeah, this is a runtime exception. So because it is a runtime exception, even though I'm saying, yeah, this can throw that exception, just like this next int method call can throw an exception, I don't have to directly handle it in my code, right? So a runtime exception that must be handled. If I just have this throw a new exception, then boom, I get an error. But if I leave it as input mismatch exception, right, then suddenly, yeah, there's no problem. Okay. Anyway, so it can be a little bit confusing, but basically exception is all checked exceptions. Direct subclasses of exception like I have here, these two, these are both checked exceptions, and you have to have them handled in your code, otherwise you're going to get errors for those. Okay. So anyway, if you have a checked exception that can arise, one possibility is use the try-catch statement, handle them locally, or the other thing, you can include in the method header something that says, this throws class happens. So if I go back here, I throw an input, throw just a regular exception, I can put it here. I can say throws exception. And then it's fine. Then I know with this, any method that calls this get value has to have this exception handling in place, because this could throw an exception. An exception is a checked exception type. Right? So if I wanted to do something in here like for no good reason, I could just do call get value. Right? I get the error there. It says I'm not handling it. Unhandled exception type exception, because it's a checked exception. So I'm going to do this. Demonstrates a checked exception now. Okay. So you can do either one of those. So a key thing, right? Suppose you have this method do work, throws an exception, and we know exception is a checked exception. Well, this one that calls it, it can put that in a try catch block, right? That's one possibility. So by calling do work, I have to have some mechanism in place for dealing it. Or I can have this method itself say, yeah, I know do work could throw an exception, but I don't want to handle it myself. I want to have some other method handle it, and it could throw the exception that way. Runtime, on the other hand, if it is a runtime exception, right? So you have this second method do work that throws a runtime exception. I could either put that in a try catch block. I could handle it. I could say, okay, I know do work could throw some kind of runtime exception. I want to handle it in this method caller A. Or I could have caller B say, yeah, I'm not going to do anything with it. I'm going to pass it onward. Or number C, I could say, or caller C, that method, I could say, yeah, I'm going to call do work. I actually don't have to do anything with that. I don't have to specify that I'm throwing a runtime exception. I don't have to handle it locally. But if an exception happens here in this do work method, then C, since it doesn't handle it locally, it's automatically going to propagate it back to whatever method called caller C. Okay. So this seems like a good breakpoint. I have a class written up, and we've covered a decent stuff. We'll finish up this, and then we'll do a little bit more stuff on Wednesday. I don't know why I'm looking through things, trying to find this Zoom button. There we go. Here I am. Okay, so I'm going to stop sharing. Questions on any of this stuff? Does all this make sense? I hope it does. All right, now bear in mind the next assignment is going to involve some of this exception handling. So you'll be doing some basic stuff with that on your own next time around. Okay, so all this thing that we have for the employee database, we're going to implement a couple things. One of them is going to be saving it to files, reading from files, and another is going to be some general purpose exception handling. So we're going to include some formatting in the database about how, you know, these various employee records can be kept. Okay, questions on anything? Otherwise, I guess we're all done. Enjoy the break.
Professor, quick question.
All right,
Will you
we'll see
have
you
a
all
chance
next time.
Hello?